Welcome to my channel. If you like my videos, then kindly subscribe, like and watch. Thank you.
Hello friends, welcome back. Problem 5-10. So in this problem it is given that draw the shear and bending moment diagram for the beam and loading shown and determine the maximum absolute value of shear and bending moment. So this is the beam and loading is shown as in figure 5-10. So you have to find, the first one is absolute maximum value of shear force, and you have to find the absolute maximum value of bending moment, and also you have to draw shear force and bending moment diagram. So let's start with the solution. The first step is to determine the reaction forces at point A and B. So for that, if I remove this support A, so there will be a reaction force which is RA, and if you remove this roller support at point B, so there will be a reaction force at point B. So first step is to apply the moment or equilibrium condition, and I will apply the first equation is sum of all moment about point B is equal to 0, and taking the counterclockwise moment as positive. So first force that is producing moment about point B is this RA. So RA into perpendicular distance is this 6 plus 6 plus 3, which is equal to 15. Clear? The second force which is producing moment about point B is this uniformly distributed load, which is 2.5 kips per feet. So you have to convert it into concentrated load. So what you will do, you will have to 2.5, and this load is over the distance of 6 feet. So this force distributed load is converted into concentrated load, and that will be acting at the mid. So from this is 3. Clear? So remaining distance will be this 3 plus 3 6, and this 6 12. So this total distance is 12, and that is the perpendicular distance. This is 12 feet. So multiply by 12, and this force is producing counterclockwise movement, so it will be positive. The third force which is producing movement about point B is 15 kips. So 15 into perpendicular distance, you can see this is 6 feet, so 6, and this is producing counterclockwise movement, so it will be also positive. So their sum must be equal to 0. When you calculate it, you will get this RA will be equal to 18 kips. Kips means kilopound. Now we have this reaction force at point A. Now we will find the reaction force at point B. So for that I will apply sum of all moment about point A is equal to 0, taking the counterclockwise moment as positive. You can also apply the other condition that sum of all forces in y direction must be equal to 0. Both will give you the same answer, but here I am applying this condition. So movement about point A. So the first force which is producing movement about point A is RB. So RB, and the perpendicular distance is obviously 15. Clear? Because you can see 6 plus 3 9 plus 6 15. The second force which is producing movement about point A is 15 kips. So 15 into perpendicular distance is 9, and this, since this is producing clockwise movement, so it will be negative. The third force which is producing movement is this distributed load. So again this load has to be converted into concentrated load. So 22.5 into 6, this will be the concentrated load, and the perpendicular distance is 3. and this is producing clockwise, so it will be negative. So 2.5 into 6 will be concentrated load, and the perpendicular distance is 3. Their sum must be equal to 0. So when you calculate it, you will get RB will be equal to 12 kips. Now you have these reaction forces, so you will have to find the shear forces at various section, shear and bending moment at various section along the length of beam. So first we will find the shear forces. We will find the shear forces along the length. So you can see at point A the shear force will be RA. So VA will be equal to RA, and that is equal to 18 kips. Clear? Now this shear force will be equal to will be at point A. Clear? Now at point C, the shear force will be equal to this 18, because 18 is over there. Clear? Minus this distributed load. So this distributed load will be converted into concentrated load. So 2.5 into 6 feet. So when you calculate this, VC will be equal to 3 kips. Now from C to D, from C to D, when you move from C to D, so at point C we have 3 kips. So from C to D, shear force will be equal to 3 kips, because you can see there is no load in between C to D. So the shear force will be this 3 kips. From D to B, when you move from D to B, so at this point D there is 3 kips, so shear force will be equal to 3 minus, and this D at point D there is a load of 15 kips, so 3 minus 15 will be equal to minus 12 kips. Okay, so now let's move and plot it over the shear force diagram. For that I have to draw this beam. The total length of the beam is, okay, this is the beam, and this is point A where RA is applied. This is point A where RA is applied. This is point B where RB is applied, and RB is equal to 12 kips, and RA is equal to 18 kips. Clear? Okay. So from 6 distance, so let me count this box: 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18 19 20 21 22, and this is 15. Okay, so what we have to do is we will take it as per, let's say, this 1 2 3 4, let this one box is 1.5, so this 3 feet, 6 feet, and okay, so from this point till this distance if this distance is 6 feet, similarly from this point till this point this distance is 6 feet, and from this point to this point this distance is 3 feet. You can also adjust it as per your convenience. So let this point is C and this point is D. So till point C we have this distributed load. You can see in a bow diagram. This is uniformly distributed load and the value is 2.5 kips per feet. At point D you have a point load or concentrated load, and that is 15 kips. So the diagram is drawn. You have to now plot the shear force and bending moment diagram. Okay, so first we will draw the shear force and bending moment shear force diagram. So you can see on y-axis we will take the shear force as the value of kips in term of kips, and on horizontal you can take the length. So this length at this point, this till this point to this point, this is 6. Similarly from this point, this is point C, this is point D, this is point A, and this is point B. Clear? Now we will decide that what will be the value of one box. So let one division over here, if I take it as 20 kips, clear, or even you can say, okay, let take one division as 20 kips. So at point A there is 18 kips, so one division is this one. Okay, one division is not sufficient, so we have to alter it. We can say one division is equal to 10 kips. Okay, let me, one division is equal to 10 kips. Okay, so at point A we have 18 kips, so this is 10 kip, and this point will be 18. Clear? So from at point A VA is 18. At point C we have 3 kips, so 3 at point C we have, this is 10, so C will be somewhere here. Clear? 3 kips. Now from C to D this will be the same because it is uniform, and from D to B this is minus 12, so this is 10 and this is minus 12 will be somewhere here. So you have to now join them. So from this is VA and this will be your point C. Clear? You have to adjust over here. Now from C to D this will be a constant line with 0-degree slope. So from this point I will draw and I will move it. Okay, let's zoom it so that you can easily move it to the point. Okay, now so from D to C, D to B, you can see the load is minus 12 kip. So I will draw a vertical line that will go minus 12. So this is 10 and this will be minus 12. Minus 12 will be there. So minus 12 will be there. And this line will go straight because there is no other load between D to B. and at B this load is 12. So minus 12 plus 12, this will become 0. Let me clear it. So from this is 10, this is 12. So from this point, this will be the vertical, and then it will go horizontal. So this will be your shear force. Now we'll move toward bending moment diagram. So again, for bending moment diagram, the area under the shear force will give you the bending moment diagram. I will write it over here. Area under shear diagram will give you bending moment. So from A to C, we have the area under the shear force diagram is VDX, and you can see this area. So this is the area. This form a trapezoid. So the area of trapezoid is 1/2 into base. Base is 6, clear, and this height, which is 18, plus this height, which is 3. Again, when you calculate it, it will be 63 kips into feet. Now from C to D, from C to D, so you can see this is a rectangle. So this length is 3 and this height is 3. So again, integral of V into dx will be equal to 3 multiplied by 3, and this area will be equal to 9 kips into feet. 9 kips into feet. From D to B, again the area under the shear force diagram, this area. So this area, you can see this height is this height is 12 and this length is 6. So 12 into 6, which is minus 12 into 6, which is equal to minus 72 kips into feet. So this area is 63 kips into feet. This is 9, and this area is minus 72. That is for moment. Now we are going to plot the moment, bending moment. So again, I have to take a horizontal line for the length. So on y-axis you will plot the bending moment, and the unit will be kips into feet. Okay. So again, here you have to decide, let one division is equal to 10 kips into feet. So at point A, bending moment at point A. So bending moment at point A, we have bending moment MA, which is equal to 0 because this force is passing through point A. So bending moment at point A will be 0. Clear? At point C, we have the moment at point A plus moment this area, this moment. So 0 plus area under the shear force diagram, which is this 63 feet. So kips into feet. So it will be 63 kips into feet. So we will draw at point C. This is point C. This is point C. So 1, 10, 20, 30, 40, 50, 60. So this will be the point at C. Okay. Now this point is 60. So this 63 will be somewhat here. So this is 63 kips into feet. Now movement at point D. So movement at point D is equal to movement at point C plus this area. So 63 plus 9, which is equal to 72 kips into feet. So this is point D. This point is point D. So this is 60, this is 70, this is 72. So this point is 72 kips into feet. And remaining this movement at point B. So movement at point B is equal to movement at point D plus this movement, which is minus 72. So movement at point D is 72, and the area under the shear force diagram from D to B is minus 72. So it will be equal to 0. So this will be the movement at point B, which is equal to 0. Now you can see that this shear force diagram is a linear line and the slope is decreasing. So the its bending moment will be the second degree curve, and that will be clockwise. So you can draw it like this from A to C. Now from C to D, you can see the shear force is a constant line with zero slope. So its bending moment will be the first degree line. So it will be a straight line like this. And from D to B, again, this is a 0 degree line or constant line with zero slope. So again this will be, and since it is negative, so the slope will be downward there. So it will be a straight line like this. So this will be your, this is point D. This is point D. So this is your bending moment diagram. So from this bending moment diagram and shear force diagram, so from shear force diagram you can get absolute maximum value of shear force. So maximum shear force is minus 72, and that is minus mod of minus 72 will be equal to 72 kips into feet, which is maximum shear force. One thing, this is not minus 72. You can see that maximum shear force is 18, that here it is 9 and here it is 12. So maximum shear force is 18 kips. And maximum bending moment, absolute maximum bending moment, so you can see maximum bending moment is 72 kips. So it is 72 kips into feet. So this is the answer of this problem, and I hope you have enjoyed the video, and if you have any question you can ask me in comment section. Thank you for watching and supporting me.